Hi guys, Ms. Raymond here, and today I'm going to show you how to use BCA tables in order to do stoichiometry, and that stands for before, change, and after. Now, if you are having trouble, please make sure that you watch this video, maybe pause it, come back to it, try to review it, taking notes for yourself on the side, but whatever you do, don't have a friend who's taken honors or AP chemistry try to explain stoichiometry to you, because they do it a completely different way. This is a new way we're doing this, so don't have somebody else explain it to you unless it's another chem teacher or somebody else in the course this year. Let's go. So in this case here, you can see we're given 4 moles of lead. How many moles of hydrogen are made? Now what's nice is that the equation is already written and balanced for you. So just know that it won't always be written for you and or balanced, so always make sure that you have a balanced equation before you start. Within the problem, I would like you to go ahead and put an underline underneath what you know, and let's put a box around what we're looking for. So we know that we have 4 moles of lead, and we're looking for how many moles of hydrogen are created or made. So what we're going to do is go ahead and in this BCA table, which stands for before, change, and after, we're going to write in that we have 4 moles of lead to start. And with that 4 moles of lead, since we're not told anything about the hydrochloric acid, we can assume that it's in excess. And excess basically we can also abbreviate as excess, so it's in excess, meaning that we have plenty of extra. Now the PbCl4 is a product, so we start out with none of him and no hydrogen either, so they both start out as 0. Our next step that we're going to do is we're going to go ahead. It said how many moles of hydrogen. What I like to do is I like to put a box around the area that I'm looking for. So I'm looking for how many moles of hydrogen are made. And really it's either one of these boxes, because the change and the after are going to be the same. So either one of those boxes is fine to put a square around. Now, the next thing I'm going to do is, since I'm not asking anything about the HCl, I'm going to go ahead and cross it out. I'm not asking anything about the lead 4 chloride, so I'm going to go ahead and cross that out. So my next step now is to go ahead and figure out what's happening to my lead and my hydrogen. Now my lead is going to go down by 4 moles because all of it's going to get used up, and at the end I'm going to have 0 moles. My hydrogen, I don't know how much it's going to change by. So what we're going to do is we're going to go ahead and we're going to start the problem by starting out with what our given is. So we have 4 moles of lead. Now please go ahead and put the unit. Okay, don't forget the unit. Don't forget what the unit stands for. It's units of lead, or moles of lead. On the bottom, we don't know how many moles of hydrogen there are for every 4 moles of lead. We're going to set up a proportion for our BCA table. So now that is our proportion, 4 moles of lead for every X moles of hydrogen. Well, where we get this proportion is from our balanced equation. And in the balanced equation, you can see up here that there is 1 mole of lead right here for every 2 moles of hydrogen that are made. So what we're going to do is we're going to go ahead and put the same units. So the units that are here in moles of lead, we're going to put over here, moles of lead. On the bottom, moles of hydrogen, moles of hydrogen. Where do those numbers come from? They come from our coefficients in our equation. 1 mole of lead for every 2 moles of hydrogen. Now from here what we're going to do is we're going to go ahead and we're going to do our cross multiply, and the easiest way of doing that is we cross multiply this way and we divide this way. So we're going to do 4 times 2 divided by 1, so our answer is 8 moles of hydrogen. So it's 8 moles of hydrogen that we are going to make. And so right now we have our final answer, and we can go ahead and put a box around it because that is our final answer. For this next one, what I'd like you to do is to go ahead and write out the question, write out the reaction, make your BCA table, and start to fill things in and try this problem on your own. As you're going, if you're getting stuck, play a couple seconds or so of this and pause it, and then try it on your own some more. Then play a few seconds, pause it, try it on your own. Or just go ahead and try the whole thing and then play and see if you got it right. Alright, so pause it now, write out the reaction, and go ahead and try to fill in the BCA table and finish this off. Come back when you're done and check it out. So in this problem here, we are given that we have 8 moles of hydrogen sulfide, and we want to know how many moles of oxygen are used up. So we have 8 moles of hydrogen sulfide. We're going to plug that in here. and we have excess oxygen, possibly. We don't know how much we have. We know that all 8 are going to be used up, and we're going to end up with none at the end. We want to know how many moles of oxygen are used up. So this right here is what we're looking for. How much is the oxygen going to change by is what we're looking for. All right, pause it and come back. Did you pause it? I hope so, because I want you to try to finish this on your own. So now we're going to go ahead and start out with our given that we have 8 moles of the H2S that are going to be used up. And we don't know how many moles of the oxygen would be needed for that, equals, on the other side here, we're going to put the same units, moles H2S and moles oxygen on the bottom. Now where those numbers come from that go along with those units are from the balanced equation. It's 2 moles of H2S for every 3 moles of oxygen. Now we can go ahead, cross multiply, divide, and we've got our answer. The answer here is 12 moles of our oxygen. So now we can plug that in over here. We're going to go ahead, oops, not plus, sorry. We're going to use up, so that's a minus. We're going to use up 12 moles of oxygen. So our question says, how many moles of oxygen are used up? Our answer is 12 moles are used up. The problems we've done thus far have been pretty easy, where we have started out with moles and of substance, let's say A, and it's asking us to get to moles of substance B. So it's been really pretty much very straightforward where we have moles of one and we're finding moles of another. But then we might find that some other problems might ask for grams, starting out with grams of A, and it wants to know, let's say, how many grams of B we are looking for. That means that we're going to have to do an extra step to go from grams to moles, and we're going to have an extra step at the end to go from moles to grams. So the ones we've been doing so far are the easy problems, basically just like the ones we've been doing, where you start with moles and you end with moles. There's going to be new problems that are going to involve mass. For instance, this one I gave here, where we start with mass, which is grams, and we want to end with mass, which is also grams. In order to do that, we're going to have to use the molar mass from the periodic table. Then there will be other problems where we're going to have volume involved. So instead of using grams here, we'll have volume, and at the end we might have volume as well. A possibility also is to use molecules. In molecules, you would need Avogadro's number, which is that 6.02 times 10 to the 23rd. So moles is easy. Mass, you'll use molar mass from the periodic table. Volume, you'll need molar volume. I forgot to mention that. And that is where we have 22.4 liters for every 1 mole of gas at STP. And then molecules, we would use Avogadro's number. Okay, so now that we've done some easy problems with moles and moles, I want to point out that the BCA table is moles only. So I'm going to make a note to myself, and maybe you want to make your note too, that BCA tables will only be involving moles. So if we have anything else, we can't put moles in there. We have to put, we have to convert from grams to moles or something else to moles before we can get started. So the very first thing I'm going to do is read through my problem. I have 22.5 grams of silver nitrate, so the first thing I'm going to have to do is get moles from that because BCA tables will only allow for moles. And I want to know how many grams of magnesium nitrate are produced. So basically what I want to know is I'm going to have to get to this, but then this will be moles, and then I can go ahead and convert that to grams because it wants to know grams. I didn't ask anything about the silver bromide, so I can leave it out. I didn't give any information about the magnesium bromide, so I can leave it out. Before I put in my before for my silver nitrate, I have to go ahead and convert that. Now, whenever you're doing problems that involve something other than moles and moles, I want you to go ahead and on the side to go ahead and write out the different steps that you're going to be taking. So the different steps we're going to take is basically that we are first going to have to convert to moles. Whoops. Not grams. We're going to convert to moles first. Our second step is that we're going to have to do stoichiometry. So I'm going to just call it stoich. Our third step is that we're going to have moles from our stoich step, and if we don't want our answer in moles, like in this case we want it in grams, then we're going to have to convert from moles to something else. So in this case, we're starting with grams and going to moles. We're doing stoich, and then from moles we're going to go back to grams. The reason why we have to do this is because whenever we deal with a balanced equation, our balanced equation, that recipe is in moles. It's not in grams. So we have to do our stoich step in moles, so therefore we have to go back and forth between grams and moles to do this. Okay, so let's get started. First thing we're going to do, we've got 22.5 grams of our silver nitrate. We don't know how many moles that is. That's what we want to convert to. On the other side, we're going to go ahead and put those same units. Silver nitrate and mole of silver nitrate. Gram silver nitrate and moles. Now, on the right side for our conversions, it'll always be 1 mole. And then in terms of gram, we're going to have to add up the molar mass of silver nitrate. We'd add up the Ag plus the N plus the 3 O's. And we would get 169.67 grams for every 1 mole. From here, we could go ahead and do our math, cross multiply, and divide and get our answer. In this case, the answer that we get is 0.13261036. And so that is our moles of our silver nitrate. So that is what we are starting out with. That is our before. So it's 0.13261036. Now all of that's going to get used up, and in the end we're going to have 0. So minus 0.13261036. Remember that this is mole. And now we need to figure out how much the magnesium nitrate is going to change by in terms of moles. So now we could go ahead and we can do our stoich step. So we know that we have 0.13261036 moles of silver nitrate, and we don't know how many moles of magnesium nitrate are going to change. We're going to go ahead on the right side, put the same units, moles of silver nitrate over moles of magnesium nitrate. Now we're going to fill in those numbers. Where those numbers come from is that it's 2 silver nitrate for every 1 magnesium nitrate. Now we could go ahead, cross multiply, and divide. The answer here is going to be 0.066300518 moles of magnesium nitrate. So that number is up here. We know that the magnesium nitrate starts out as 0. We're increasing by that amount. And so therefore, in the end, that's what we end up with at the end. Now, we're not done though. Remember, our question didn't say moles. It said how many grams, not how many moles, but how many grams. So we've got one more step here to take. And this one last step here, we're going to go ahead, we're going to start out with what we just found. And it's nice if you don't clear your calculator, because you've already got this stuff in your calculator, and then you can just go ahead and continue on, like hit multiply when you're cross multiplying and then dividing. So that way you don't have extra steps you have to take. Now I'm going from moles to grams in this case because my question wants grams. So I know how many moles I have for every X grams of magnesium nitrate equals, on the right side here, I'm just going to change color just so it doesn't blend in with my other black there. So on the right side here, I want moles of magnesium nitrate and grams of magnesium nitrate. Now remember, along with the word mole, it always comes 1. And with grams, that I have to look up on the periodic table. 1 Mg, 2 nitrogen, and 6 oxygen. The molar mass of magnesium nitrate, by adding all that up, is 148.33 grams for every mole. So from here, we're going to go ahead, cross multiply, divide, and we've got our answer. Our answer here, and I've run out of space, sorry about that, but our answer here, I'm going to go ahead and put in green, just for sake of choosing another color. I'm going to put in green over here on the left. Our answer, after cross multiplying and dividing, along with sig figs, because I had 3 sig figs, it's 9.84 grams of magnesium nitrate. So here is finally my answer. I finally have my answer over here in the lower left corner. I'm going to go ahead and put some boxes around it so I know that that's my answer. So again, just to review, you would go ahead and you would first have your balanced equation. The first thing you would do is break it down. So I know that I'm going to have to go from grams to moles. Then I'm going to have to do stoich. Then I'm going to have to do moles to grams. So now I go ahead and I take those 22.5 grams, put them down here. For every X moles, I'm going to go ahead and make the same unit. I've got grams of AgNO3 up here on top, and so I'm going to go ahead and put grams of AgNO3, moles of AgNO3, moles of AgNO3. Cross multiply and divide, I get my moles of AgNO3. I plug that in over here. I do my BCA. Now I want to find out from my stoich. So from my stoich, I've got those moles of AgNO3. I don't know how many moles of magnesium nitrate. I set it up with my stoichiometric ratio. Cross multiply, divide. Lastly, moles to grams step. Take those moles over X grams. There's 1 mole for every molar mass of the whole thing of magnesium nitrate. Cross multiply and divide. And I end up with my final answer. So down here in the lower left corner, this is my answer to this problem. Now, if you're still having some trouble, I would go ahead and try some more problems in your packet and come and see your teacher before or after school or during lunch or study hall if you need some more help. Thanks.